So in the previous class we saw about the step up and step down transformers, right? So apart from this, based on the construction of transformer, we can classify a transformer into shell type and core type transformer, right? So this is based on the construction, right? So this is the construction of a core type transformer, right? So this construction is similar to the one which we saw in the previous lecture, right? So an iron shaped core, and we have a primary winding on the left hand side and we have a secondary winding on the right hand side, and in between we have an air gap. So this is the basic construction of a core type transformer, right? So in this type of construction, only half of the windings are wound around each leg, right? So this type of construction ensures that the magnetic lines of force flow across both the windings simultaneously, right? So but it has a disadvantage too. So the disadvantage is it has some leakage in magnetic flux. So due to this, the magnetic lines of force which is outside the core, so due to this we have a small magnetic flux loss. So the second type is a shell type transformer. So in this shell type transformer, both the windings are wound in a single leg of the iron core. So due to this, what will happen? The magnetic flux losses will be highly reduced, and whereas here the heat generated will be more compared to the core type transformer, right? So in the shell type transformer, the primary and secondary windings are positioned cylindrically on the center limb. So what will happen? It results in twice the cross-sectional area than the outer limbs, right? So there are two closed magnetic paths in this type of construction, and each outer limb has magnetic flux of 5/2 flowing in them. So 5/2 in the outer limbs, right? So this shell type transformer, it overcomes the leakage problem in the core type transformers, and since we are reducing the leakage, we are reducing the core losses and increasing the efficiency of the transformer. So this is based on construction, right? So this is the basic advantage of any type of transformer, right? So a transformer, it is stationary equipment, so without any moving parts as compared to DC machines. So it doesn't have any rotating parts, right? So hence the operational and maintenance cost will be less, and its operational efficiency is very high, up to 99%, right? So besides facilitating power supply at different voltages, it can also be used for measuring and protection applications, and also it is used for earthing of neutral of a power. So now we are going to see the types of transformer based on different applications, right? So in case of power and distribution, we call it as power and distribution transformer, right? So distribution transformer is the transformer which distributes the current to different areas of our commercial line, right? So that is the distribution transformer. And the next one is the instrumentation transformer. So instrument transformer, it is used for measurement of voltage, right? So it measures the voltage, and it is also used for protection. So that type of transformer is instrument transformer. And then earthing transformer, so earthing of a power line. And finally a rectifier transformer. The rectifier transformer, it is used for providing controlled power supply to different processes. So further, this power and distribution transformer can be classified based upon the construction. So as we already saw, core type and shell type, and then as per the number of phases, we can classify it as single phase and three phase, and then as per winding, you can classify it as single winding, two winding and three winding transformers, right? And then as per voltage, you can classify it as low tension. So up to 650 volt, we call it as low tension transformers. Then from 11 kV to 33 kV, high tension transformers. Then from 66 kV to 400 kV, it is extra high tension. and after 765 kV it is called as ultra high tension transformer. And then as per voltage ratio we can classify it as step up and step down.